Here we'll do extra practice on writing polynomials based on graphs. We'll find the zeros and their multiplicity first. Let's box in our zeros on the graph. We can see that we have a 0 that is halfway between -2 and 0. Since it's halfway between -2 and 0, we'll say that's at -1. We also have zeros that are marked at 2 and 4. We'll begin by writing x equals -1, x equals 2, and x equals 4. We'll also look to the graph to establish their multiplicity. At the -1, we have it squiggle as we go through the axis. If we have a squiggle, this will give us a multiplicity of 3. At 2, we touch the axis but bounce back off, and when we touch and bounce back off, this gives us a multiplicity of 2. Finally, we cross straight through at 4, and when you cross straight through, this gives you a multiplicity of 1. Now that we've established the zeros and their multiplicities, let's set each piece equal to 0. Let's begin with the piece on the left, x equals -1. If we want to set that equal to 0, we will add 1 to both sides. This will give us 0 on the right and x plus 1 on the left. Since that's multiplicity 3, though, we'll start by saying y equals, and then parentheses x plus 1, and raise that to the third power because that's the multiplicity. Next, we'll move over at x equals 2, and then we'll subtract 2 from both sides because when we take 2 minus 2, we'll get 0 on the right, and then we'll have x minus 2 on the left. This means our next parentheses in the polynomial is x minus 2, and since the multiplicity at that position is 2, we'll raise this to the second power. Finally, we'll look to x equals 4. We'll subtract 4 from both sides to get our 0 on the right, and we'll have x minus 4 on the left. Our final term in the polynomial will be x minus 4, and we'll raise that to the invisible 1 for first power, or multiplicity 1. Finally, we'll need to find the a in front of it. We've done most of our work for this polynomial, but let's move to the next page and look for a. In order to find a, we'll look for some definitive points on the graph. There are a couple of points we could use. We do have a point that's fairly easily marked on this graph at this first green box I'm drawing. On the graph, we may be able to see that this is at 3, 4. This will work, and we could set x equal to 3 and y equal to 4, but there is a better choice on this graph here at the y-intercept. At that y-intercept, we have x equals 0 and y equals 1. And so that point 0, 1 is going to make our math for finding a little bit more straightforward. Once again, either point will work, but the easier option is to let x equal 0 and y equal 1, because we know that point is on the graph. In place of y, we'll say 1, and we'll say equals a times 0 plus 1 to the third power, times 0 minus 2 to the second power, times 0 minus 4 to the first power. Let's simplify now. If we take 0 plus 1, that's 1, and then raised to the third power gives us still 1. We also have -2 raised to the second power, that's going to be positive 4, and this will be multiplied by 0 minus 4, which is -4. So we now have 1 equals a times 1 times positive 4 times -4. If we multiply all of the terms together, we'll get -16. Therefore, we'll have 1 equals -16a. Then we divide both sides by -16, which means that we can cancel out the -16 on the right, and we can say that a equals -1 over 16. Noting that we don't have to write that negative on the bottom, we could take that negative out to the left side and stick it in front of this fraction. Now that we know that a is -1 over 16, we'll have y equals -1 over 16 times each of our terms. X plus 1 to the third power times x minus 2 to the second power times x minus 4 to the first power. This will be our completed polynomial.